So looking at our graphs from our Delta Math assignment, where we're interpreting the graph of our linear functions, they're a little gray. They're going to look better on your paper because my prints didn't show my axes for each number. But there's roughly a linear relationship between the number of times a species of cricket will chirp in 1 minute, so 1 minute, and the temperature. Oh, that's the wrong one. Oh, hello. Let me back up. Sorry, it all ran together. Okay, so discussing our Delta Math practice with our word problems in a graph. And sorry, they're kind of squished together. I wanted you to not have to print too many pages. But first, Madeline is going to the amusement park where she has to pay a set price of admission, which is going to be set price. Hopefully, we're going to get to where we know that's going to be our y-intercept. That's that guy right there. And another price for tickets to go on each of the rides. Madeline made the linear graph below to indicate the money she might spend in total. What does the y-intercept in the graph represent? So y-intercept, again, this is your y-axis, this is your x-axis. You want to make sure you're paying attention to what is labeled, so number of rides, and it's going to be our total cost. This is where it matters if you know your input versus output and independent versus dependent. X is always your independent. So that's what you control. You decide how many rides you're going to take, which determines the cost. And so then your y value or output is always dependent on the other. So the cost is not independent of the number of rides. You will know what it costs to take a ride or to spend the day at the park depending on the number of rides you rode. So what does the y-intercept mean? Again, that's going back here. So where it crosses that y-axis, it's the cost to get into the amusement park, the change in total amount of money for every one additional ride she rides on. So as soon as you see change, you know this should be slope, rate of change, right? And the total amount of money Madeline will spend if she goes on 100 rides. So that 100 would be your X value, which means the total is usually always your output or your Y value when you plug in a said input or X value. A total cost of $26.50 when going on one ride. We know one is right here. And there's our $26.50, but is that the y-intercept? That's not where it touches the y-intercept. That is just plugging in a 1 and getting an output. So the $24, which is your y-intercept, is the cost to get into the amusement park. So as soon as you walk in, you're going to spend $24, and you'll start to spend more depending on the rides you ride. So there's roughly a linear relationship between the number of times a species of a cricket will chirp, so chirps per minute, in 1 minute, and the temperature outside, so our temperature. As expressed in the graph below, what is the meaning of the x value, y equals 75? So I want to go to y equals, and y's are up and down, so it's going to be right here. And again, my lines are a little gray and harder to see. But I'm going to go all the way across until I touch my function. Come over here, and then I'm going to go down. And it looks like we want to discuss that it's counting by 20s. So 20, 40, 60, 80. So that means right here in the middle would be 150, right? And then, or, this is our 0. This could be 30. So you just want to pay close attention to the way it's counting and knowing that temperature is our output, which depends, so it's dependent on the chirps per minute. And that's because they put this on the x-axis. The x-axis is your input or independent variable because they are saying this controls, you can read the temperature. All right, so it says, what is the value of 75? We got 150. The expected temperature in degrees Fahrenheit is a cricket has chirped 150 times per minute. That would be 75. So 150 per minute would be 75. So this one's looking good, but we're going to make sure. The number of times the cricket could be expected to chirp in 1 minute if it's 150 degrees Fahrenheit. But that's not right because 150 degrees Fahrenheit is going to be your Y value. So the number of times a cricket would be expected to chirp is your X value. So if that's at X equals 75, we could go back and check our numbers. But the number of times the crickets chirp is an X value, and this is a Y value. So that's how you know that's not it. The number of times the cricket would be expected to chirp, again, that's an X value, in 1 minute if it's 75 degrees Fahrenheit. So the number of times, that's not the Y value. What is the meaning of the X value, right? Oh, I read it wrong already. So this is looking at the number of times the cricket would be expected to chirp is the X, unknown. Whereas before, the expected temperature in degrees, if the cricket chirped 150 times per minute, the degrees is our Y value. That's why this one's not right. Because our question, and this is where I've said many times, and I do it, everyone does it, as you're reading, Make sure you read your answer choices, read your question, read your answer choices, read your question again, and then make sure, because otherwise you would have probably jumped. I would call this your dummy answer, not calling you a dummy. This is the one that you would be like, oh, there it is. There's my 150 that goes to my 75, but you have to make sure you're reading it very closely. And then last but not least, the expected temperature in degrees Fahrenheit if the cricket chirps 75 times per minute. And unfortunately, that 75 is not what we're discussing anyway. We're discussing what is the X value. So it needs to be the chirps per minute, not temperature. Because if we're discussing temperature, that is your Y values. So our answer is going to be the number of times the cricket would be expected to chirp in 1 minute if it is 75 degrees outside. All right, so moving right along. So this is your open-ended. So Nathaniel was given a gift card for a coffee shop each morning. Nathaniel uses the card to buy 1 cup of coffee. Let A represent the amount of money remaining in the card after buying X cups of coffee. So number of cups of coffee is our X, and A is our Y value, amount of money. A graph of A is shown below. Write an equation for A, then state the slope of the graph and determine its interpretation. So we know we start at 50. So that means that card had $50 when you started, right? And that's our Y-intercept. So if we're looking at Y equals MX plus B, because we're starting with $50, that's going to go in the place of our B. Now we have an X. We just need to find our Y. Now, when I bought 1 cup of coffee, it took some money, but that's not a good intersection. Let's go right here. So 2 cups of coffee, I lost $5. And I want to check it. And then 2 more cups of coffee, I lost another $5. Every $5. So it's $5 per cup of coffee, right? Do it one more time. So 40 to 35 for every 2 cups of coffee. I'm sorry, 6, because this is 4, 6. So for every 2 cups of coffee, it's $5, which means 1 cup of coffee. So if 2 cups equals $5, then 1 cup is going to be $2.50. So it's going to be a negative $2.50 because it's also decreasing. You see the line going down. X plus 50. So we now know that each cup of coffee is going to cost him $2.50. And again, the reason I use 2 is because I'm looking for good intersections. If you saw the 250 in our halfway marks, great job, and that's awesome. And the reason they use these as hard dots, it does mention it instead of a solid line, is you don't get 0.375 of a cup of coffee. You either have a cup of coffee or you don't have a cup of coffee when they're charging you at the store. So the interpretation would be slope, $2.50 per cup of coffee. And that's how much it's going to go down. So Camden is in the business of manufacturing phones. He must pay a daily fixed cost to rent the building and equipment. So daily fixed cost, as soon as you see fixed cost, you want to think Y-intercept. He pays a daily fixed cost to rent the building and equipment, and also pays a cost per phone, so that's going to be your slope, produced for materials and labor. Let C represent the total cost in dollars of producing P phones in a given day. The graph of C is below. I write an equation for C and then state the Y-intercept, so we're looking at Y-intercept of the graph and determine its interpretation in the context. So Y-intercept is where it starts, so that's going to be 400. So our B is 4. And then for number of phones, if I go to my 1 phone, it looks like it goes up $100, up $100 for 1 phone. So it looks like each phone is $100. So up 100 over 1, because 400 to 500, even though it looks like 1 to 1, you're looking at how it's counted. So 100 over 1. So that means our equation is Y equals for every $100 after you pay your 400 is going to be your monthly cost. And that depends on how many months, which would be your X value, that you kept your phone. And then it said to interpret your Y-intercept, it's a $400 daily fixed, daily to rent the building and equipment per phone. Number of phones, this is the cost. Yep, so it's daily fixed cost. So every day, it's going to be $400. So every day, you will pay $400. And then this is going to be the daily cost. So this is going to be 1 day's cost. All right, guys. Hope that helps. Hope Delta Math doesn't stomp your butt. If you need anything, holler.